Alrighty. I think we're kind of ready to start, slowly but surely. Again, I want to say we have the upstairs area. We're doing our best with the drinks and stuff. Your lot. And I hope you're having fun so far. Thank you. I'm going to keep it short. It's my time to introduce our next speaker. He made it all the way from Australia to Austria. Might be the furthest traveled speaker. I'm not 100% sure, but definitely far, far away, all the way from Tasmania. He's going to talk. He's a former comedian, he assures me, but I think I saw a sneak peek of his slides. I think it's kind of funny. So please, it's my pleasure to welcome our next speaker who's going to tell us a bit about reindeer and daring to be different. Please welcome Maedi.
Yeah. Thanks, everyone. Yeah, I've only got 2 funny slides. Don't expect comedy. I'm not funny anymore. Yeah, so Raindeer is a web framework that I've made over the last 6 months. And it's a bit weird to be here because I didn't intend to make a framework at all. Like 6 months ago, I was just working, coding on my laptop, making a Sudoku solver. And I was watching all 5 seasons of Prison Break and the miniseries, which is it's a really good show. 2 brothers trapped in prison, always escaping prisons, making friends along the way. I would really recommend it. And I was just coding this Sudoku solver, and I wanted types. And I was lazy, so I just put a string in the default value field, because I'm lazy. And that has become what I call a type expression. And if you can accept this, as you see it there, when there's a type, it's a type expression, checking types and defining types. When it's a value expression. If you can make that one simple change to your mind, then we can actually go a long way. So with LowType, it is basically a type checker at runtime, and then you can export it to RBS if you want. And you can enable it just by including it on the class. You can sprinkle it in anywhere you want. It's completely optional because I do love duck typing. I just think sometimes it's nice to do a little bit of self-documentation. Or you can add a magic comment at the top of the class saying type expression is true. And there's 3 ways to use it, where you can strip types on class load, on build. I really love not having a build step, so it works out of the box with no build step. And here are some examples of it. So that's what a default value looks like, a string that has a default value of hello. We support enumerables, an array of strings, a hash with a string and an integer, key value, pair. You've got return types. This is all valid Ruby. And then we've got a nullable return type there with a string or nil. We've got type accessors, which are just attribute accessors, except the type is checked on the way in and the way out. And local variables, where here we're fetching an object that has to be of type, my type. And I think by this point you can see my hidden agenda. I really like minimalism. And here's another expression. So those were type expressions. The beauty about LowType is it works at runtime, so we can do a lot of cool things. So this is a dependency expression where that logger argument is being injected from a dependency, an auto-injection framework called providers. So you just put the dependency expression class there, and that logger arg will automatically be injected, and you can mix that with local dependencies. It works great in unit tests, that kind of thing. And if you don't want to call your arg, your dependency logger, you can provide a default value there, and you can actually call it, you can get it from a logger provider. And that is an expression. So these are all expressions, type expressions, dependency expressions, and they all follow that syntax down the bottom right there, where there's a collection option or a default option. And I use a few expressions throughout Raindeer. And I got one more secret agenda. I also want to fix the existing world. So here we've got Sinatra, and I think that Rack, and therefore Sinatra, it's so arbitrary having those 3, if there's array of 3 elements there with the status code, the headers, and the response. And so I've come in here and I've just put types on it. And that's real working code that you can use today. And there's a generic example, and then a very specific example for Sinatra there with the tuple. Raindeer is built on Low Ruby, which is a set of gems that are designed to be pretty generic that you can use in existing applications, especially the first three, which don't communicate via events. So LowKey is actually wrapping Prism. We've heard a lot about that today. And that is basically the secret source for LowLoad and LowType, which have all the access to the metadata of the file. And with LowKey, you can very easily access all of these proxies and get the data you need pretty quickly. And then LowLoad is an auto loader, and it's different to Zeitgeist. It doesn't need your folders to match your module. And so it's basically just that line. You just run that, and everything gets imported. It already knows where all the dependencies are. And then, of course, LowType. And Raindeer comes along, and it basically glues everything together with these providers, these observers, these expressions, and a router. And here's the architecture. It's event-driven. If you look over on the right, you've got the on the horizontal axis, you've got the 3 sample example requests, but it could be 1,000. And all those requests come in at the exact same time, and they're being asynchronously forwarded through the router. They create all these events. They create route events. And then that data is a response given through what I call a LowNode. And along the vertical axis there, with those LowNodes, there's room for parallelism because we automatically make all of that data immutable by that point. And so I think it's a pretty good architecture for scalability, but also just in the one space of memory. And it's important to mention that although it's event-driven, your application doesn't have to be. You can just use the same patterns that you're currently using. It's good enough just for the framework at a high level to have that observability built in. And so nothing has to change on your side. And Raindeer is very compositional, and you'll see that in some later examples. And the mission is, we all know Ruby's great, but why doesn't the rest of the world? And I want to try to change that a bit, because we know it's simple and elegant and powerful. And also now it's concurrent. It's got reactors and fibers, and these things are amazing. Like, they are so usable compared to other programming languages. You don't even have to know that you're not in a synchronous world. And also, it's really trying to popularize event-driven technologies because the world is event-driven, and I think that it actually makes the code easier to read when you have a few key events happening. And also, the third goal here is to integrate with every layer. The very first request is captured as a request event, and you can follow that through a series of events all the way through the application to the database and back. There's no rack here. We don't use rack, and I think it might be the only framework doing that. So we'll see how that turns out. And there's going to be a distributed layer, which we'll talk about at the end, which is using those events to scale quite simply. So let's just go through like a typical life cycle through some of the gems, starting at LowLoop, which is an asynchronous event server. And it's built upon the async gems and the protocol HTTP gems. And it basically starts off this process where you get LowLoop takes in the request, and it makes a request event, and then the router responds to the route event, and so on. And it's also in charge of just long-running jobs and pipelines and that kind of thing. But it's doing it in a way where, from the application's perspective, it doesn't matter if it came in as a request or if it's a long-running job. It still feels the same. It's still the one cohesive application when you use it. So LowLoop will create a request event, and then the router will listen for request events and match it to the correct route. This is a prefix-tree. It's very efficient. And these two examples are equivalent, but the top one's making two different kind of route events, so you can listen to subpaths in the route. And the bottom one there is just making one route event, uses ID. And so you basically listen for that request, and you make a route event from that path. And then a LowNode comes along and observes that event. It observes that route, uses ID. And then it returns a value. So LowNode is the basic building blocks of your application. And there's no MVC here. You're going to follow your own patterns anyway. You're going to do what you want to do. And so it's just at that request, it's at that layer where it meets the external to the internal and lets you do your thing. But it does a few cool things. It's compositional, so you can call other nodes from it, you can call other code, and you can respond in a few different ways. So it's just at that right layer to let you do what you want to do. And it enables parallelization, which I'll show you soon with Atlas. So in a LowNode, you can chuck HTML in Ruby, and it's called RBX, and it's just like JSX, but it's Ruby, and that's that. And then Atlas comes along, and you can basically embed a node within a node. And so here we've got a child node being embedded into a parent node. There's some HTML around it. It doesn't have to be. You can just put nodes inside nodes. And here is a full detailed example of what that would actually look like. You'd be observing a route. The parent would be listening for that route event. It would be then rendering a child node. And the child node gets a render event, which is where things become immutable if you want them to be. So you can use parallelization later. And then you return a value. So it's compositional and event-driven. Oh yeah, and although this is like an example representing the front end, like a component in a React component, it doesn't have to be. It's conceptually both sides of the equation. It can be that's why they're called nodes. They can be front end components or more abstract back end concepts. Here's a parallelization example with Atlas. You just wrap some parallelized directives around it. And so here in this example, just remember, everything's asynchronous by default. So this won't always help you, because if the user node and the post node nodes are getting data from the database, they're all going to return data at practically the same time. But if you have something highly CPU intensive, or you want to do something really fast, and you can parallelize it, wrap these tags around it, and that'll make it faster. And then the second example there is just a map of doing the same thing. And it's easy to get scared in parallel land. Just know that it's basically asynchronous by default. Usually, it can be parallel here, but it's always asynchronous if you're observing an event. You can always reach back up to the top level and know that you're in asynchronous land where you can access global state. You don't have to use parallelism. And we've got a few ways to render a node. We've got the HTML way, which you've kind of seen so far. We can talk to a client-side React framework, for example. Here we're just returning JSON. And I'm experimenting with the best of both worlds, where you render a request with HTML and then basically listen on a port with WebSockets to something like users.id and basically sync that data two ways. The next thing is LowData. How do we get that? How does that find method work? Sorry, I'm recovering from something. So it's just a repository pattern, and you can use the SQL gem. It's all very standard, but there might be a model one day, like a low model. But for now, plain Ruby objects are fine. But there is a twist, data expressions, where you can just write simple expressions that create a SQL query on your behalf. So here we've got, that's a good idea. When you travel from Australia, it'll fuck you up. So this data expression is basically creating an SQL query to get posts from the post table, and it's going to just return a title and a body. The second one's doing the same thing, but it's adding a where clause, and it's filtering by user ID. And what I really want to do is this. I want to invert the logic, and I just want to care about the table I want, and I want LowData to go figure out which tables that comes from. And so when you think about it, the data's already there. Like, we know that we want a post table, we've got a title and a body, and we know that that post table probably has a foreign key to a user table. And so theoretically, you could do this. That's what I want to do. But if you want to remain hinged, you can just do this. And you can get those two tables and join them together. This plus, it's an outer join, but you can do an inner join, a left join, or a right join. Oh yeah, I meant to demo this thing. So here I'm just refreshing the page, and I've made a little matrix data visualization so you can see what's happening here. So I'm getting the home page, it's 404, that's great, because it's creating a status event of 404, and we listen to that event, and we put back a 404 response. But if we go to this little internal dashboard that I made, that lists a few stats, and go over look at the events, and we've got all the observers for all the events, and all of the routes for the route event, just give you a bit of information, and you can really spam this thing, make lots of funny events. It's requesting files, it's requesting the web page, of course. And yeah, that's really that bit. I like to watch it fade away, so we'll just wait for it to fade. There we go. One more. Yeah. So events, because I haven't really talked about events, but the whole thing is event-driven. You're just observing these events, but it is not events. It is not events in the classical sense, where they always happen in the past, where you can't do anything about it. Low events are really focused on the present, where you can actually do something and change things. And then commands, which are future actions. So we're kind of in between, and we're a hybrid, and we're both things. And our naming scheme is different. Oh yeah, so we're just focused on what's happening now. Our naming scheme is different. I really dislike how we can call classes with past tense. I just think that's wrong. And so we don't have the action in the class. It's just present tense. It's an order event, and the action is a separate thing. Just a symbol there, create order. And they're mostly immutable, but there is a little bit of mutability for tracking a hierarchy, which I'll show you soon. And it's got some very basic state where you can loop through some predefined actions. And the difference, really the big difference to normal events is that they always have to return a value. It's a request response. You're always expecting something back, and that allows quite a simple flow. We're going through many, many events, and then you get one bit of data back. And so you have these events, and then you have the observers of those events, and it's all decoupled, and that can sometimes be a bad thing, because it's all just random bits of data on random servers. And so we've knuckled it back down, where you can basically open up any event, and you can define who observes that event, and in what order. It's just an array. And I think that's really important to hardcode that in, to make things simple. It's very linear from A to Z, and you always know which observer will observe your event and in what order. And so because of that, because of that linearity, you end up with this tree that is always the same. It's deterministic. You have a request, it goes through a bunch of routes, it finds one, it renders a response, maybe does some things on the side. And when you have something that's sort of deterministic like that, it's basically a pipeline. And everything in Raindeer is a pipeline. Events are pipelines, pipelines are pipelines. There's a user update pipeline there. Event observers are pipelines, as you just saw before. They're in order. And event actions are pipelines. This one's more advanced, but you can make an event action different actions on multiple observers if you really want to. Still thinking about that one. I really like this scorecard from the book Fundamentals of Software Architecture, where it ranks all these structures. Now, Raindeer is both of these. It's a modular monolith that's very event-driven leaning and will one day completely scale in an event-driven manner, which I'll talk about on the next slide. And so I'm trying to combine the best of both worlds here, where we are getting that simplicity in this one big heap of memory, but then everything does have to scale eventually and annoy you. And so I'm trying to avoid that. With ecosystem, which is the distributed part, which is an event broker, maybe a load balancer. It doesn't have to do that, but it could. And that's just responsible for those high-level pipelines and jobs. And service events, which allows providers to communicate across apps. And so you may remember providers from before, where it was just injecting dependency, but you can inject dependencies across applications. It could be an identical Reindeer instance, or it could be like a microservice. But that's the idea with providers, is that you access that service from another instance, and you put it into your application, and you use it to just give you the illusion that you're in the same space in memory, just to make it easy for people. Because that's what I'm all about. I hate how complicated things are. And here we're taking in that event, and then we're just continuing on as normal. And that would look like this in the tree. And I forgot to mention that this tree is created for every request. And so you have great observability, and that's how I made that matrix before. It's just outputting what is in this tree. And so the purple there, the service event, it is in another instance, and it comes back to us and provides all of that history along with it. All these events happen in this history, comes back to this bit of memory, and you can actually see what's happened, rather than have all these disparate servers running on all these different queues and never really connecting what's happening and getting 3 errors in different places. It's a mess. And that's Reindeer. Thanks.
Thank you so much for coming here all the way from Australia again. Again, we're going to do a short break, 20 minutes or so. Grab a drink, grab something to eat, and I'll see you back in 20 minutes for our first piano performance, which is a bit of a teaser for tomorrow. There's going to be a lot of music here. So yes, see you all in 20 minutes. Thank you.